Welcome back to Zito TechVerse. In this video, we're covering 30 Java full-stack interview questions for 4+ years of experience, spanning core Java, Spring Boot, microservices, and more. For each, I'll provide the question and a clear, structured answer. Let's begin. Here is our roadmap. We'll start with core Java and the JVM, move into Spring Boot and REST APIs, explore microservices and system design, and wrap up with front-end, database, and DevOps topics. Let's start with Section 1, Core Java and the JVM. Question 1. How does the JVM manage memory? The JVM splits memory into the heap, which stores objects, and the stack, which handles threads and method frames. Metaspace stores class metadata. Garbage collection runs on the heap to reclaim unreachable objects automatically. Question 2. What is the difference between equals, equals, and equals? The double equals operator checks reference equality, while equals checks logical value. Always override both to maintain the hashcode contract, otherwise collections like hashmap will fail. Question 3. Explain the Java memory model and volatile. The JVM manages how threads see shared variables. Volatile ensures visibility by forcing reads and writes directly to main memory, though it doesn't guarantee atomicity for compound operations. Question 4. How do hashmap and concurrent hashmap work? Hashmap uses buckets and handles collisions with chains or trees. Concurrent hashmap is thread-safe, using fine-grained locking or CAS to allow high concurrency. Question 5. What are the benefits of streams? They allow declarative, functional data processing. Parallel streams use the fork join pool, but use them only for large, stateless, CPU-bound tasks to avoid overhead. Question 6. Explain functional interfaces. They have exactly one abstract method. Key types in java.util.function include function to transform, predicate to test, consumer to act, and supplier to provide values. Question 7. How do you diagnose and prevent memory leaks? Look for rising heap usage or frequent GC. Common causes include unclosed resources or static collections. Use tools like heap dumps and Eclipse Mat, and always use try with resources. Moving to Section 2, Spring Boot and REST APIs. Question 8. What is dependency injection? It's a pattern where objects receive dependencies rather than creating them. Spring manages this via its container, with constructor injection being the recommended practice for testability. Question 9. How do you design a clean REST API? Use nouns for resources and HTTP verbs for actions. Return standard status codes, version your API, and always use DTOs to decouple your internal data structures. Question 10. How do you handle exceptions globally in Spring Boot? Use REST controller advice to centralize handling. This allows you to map specific exceptions to consistent error DTOs, keeping your controllers clean. Question 11. How do you implement JWT authentication in Spring Security? Validate credentials at login to issue a signed token. Then, use a filter to validate that token on subsequent requests to secure your stateless API endpoints. Question 12. What is @transactional and how does propagation work? The @transactional annotation wraps a method in a database transaction. It ensures all operations either commit or roll back together. Propagation controls how nested transactions join or start new ones. Required joins existing transactions, while requires _new starts a fresh, independent one. Question 13. How do you handle concurrent updates with optimistic locking? You add a @version field to your entity. JPA increments this version on each update. If the version doesn't match upon saving, JPA throws an optimistic lock exception, preventing data from being silently overwritten. We are now moving into Section 3, Microservices and System Design. Question 14. Monolith versus microservices. When to choose each? A monolith is simple, offering one deployable unit and one database. Microservices provide independent scaling and deployment, but add significant network and operational complexity. Start with a monolith, then split when your scale or team size demands it. Question 15. How do services communicate? Use synchronous REST or gRPC for immediate responses, or asynchronous messaging with Kafka or RabbitMQ for decoupled events. Sync couples availability, while async improves system resilience and handles traffic spikes effectively. Question 16. What resilience patterns keep microservices stable? Use a circuit breaker to fail fast when a service is struggling. Retries with backoff handle transient issues, while bulkheads isolate resources. Fallbacks allow your application to degrade gracefully when things go wrong. Question 17. How do you keep data consistent across microservices? Since you cannot use distributed transactions, use the saga pattern for eventual consistency. Sagas are sequences of local transactions, where each step has a compensating action to undo changes if a failure occurs. Question 18. What is an API gateway, and why use service discovery? The gateway acts as a single entry point for routing, auth, and rate limiting, hiding internal topology. Service discovery tracks live instances, enabling load balancing even as your environment dynamically scales. We are now moving into Section 4, Front-End, Database, and DevOps. Question 19. How does the React Virtual DOM work? It's an in-memory representation of the UI. When state changes, React re-renders to a new virtual tree and compares it to the previous one using diffing. It then patches only the minimal necessary changes to the real DOM. Question 20. Explain the JavaScript event loop and async behavior. JavaScript is single-threaded. Async operations use task queues. The event loop monitors the call stack, moving queued callbacks to the stack once it is empty, with microtasks running before macrotasks. Question 21. What are React hooks? Hooks allow function components to use state and lifecycle features. Use useState for state and useEffect for side effects, using the dependency array to control execution. Only use hooks at the top level of your component. Question 22. How do database indexes work? Indexes are sorted structures that turn slow full table scans into fast lookups. They speed up reads but add overhead to inserts and updates. Index selectively on columns frequently used in filtering or joins. Question 23. SQL versus NoSQL. How do you choose? Choose SQL for structured data requiring strong ACID consistency and complex joins. Choose NoSQL for flexibility, horizontal scaling, and high throughput. Many modern systems use both, implementing polyglot persistence. Question 24. How do you diagnose and fix a slow SQL query? Use explain to analyze the execution plan. Look for full table scans or inefficient joins. Add appropriate indexes, avoid selecting all columns, and watch out for the N+1 problem in ORMs. Question 25. What is Docker, and how does it help full-stack deployment? Docker packages your application with all its dependencies into a single container, ensuring it runs identically in every environment. This eliminates the "it works on my machine" problem. It's lighter than a virtual machine, and tools like Docker Compose make running multi-service architectures simple. Question 26. What does Kubernetes add on top of containers? While Docker runs a single container, Kubernetes orchestrates a fleet of them across multiple machines. It's declarative. You define the desired state, and Kubernetes maintains it. It handles self-healing, auto-scaling, rolling updates, and service discovery, making production deployments resilient and automated. Question 27. What is a CI/CD pipeline, and what are its typical stages? CI/CD automates the transition from code commit to production. It includes stages for building, unit and integration testing, security scanning, image packaging, and deployment to staging and production. It ensures every release is repeatable, tested, and reliable. Question 28. How do you make a full-stack app secure? Follow OWASP essentials. Validate all inputs to prevent injection, use parameterized queries, and enforce authentication and authorization on every endpoint. Use HTTPS. Hash passwords with strong algorithms. Keep secrets in a vault, and keep your dependencies patched to avoid known vulnerabilities. Question 29. How do you implement caching, and what pitfalls should you avoid? Caching stores frequently accessed data in memory to reduce latency. Key practices include setting TTLs and using eviction policies like LRU. The biggest pitfall is cache invalidation. Always update or evict the cache when data changes to avoid serving stale information. Question 30. How would you design a system to scale to millions of users? Design stateless services that scale horizontally behind a load balancer. Offload static assets to a CDN. Use caches like Redis, and add read replicas or sharding for your database. Finally, use asynchronous messaging to decouple services and handle traffic spikes. That wraps up our top 30 Java full-stack interview questions. If this video helped you prepare, please like and subscribe to Zito TechVerse. If you have a specific topic or a tough question you want me to cover next, let me know in the comments. Good luck with your interviews.